All right, welcome. Today we're talking about composing functions, and now that I can spell composing right, that's good. And the reason I brought this example up is because it involves a radical. So when we're composing functions, the first thing that we want to talk about and discuss is domain. And we've talked about domain of rational functions, which has something or some expression in the denominator. And we do x minus 3 is equal to 0, x cannot equal 3, and we put that because any fraction with 0 over it is not going to give us a result. There won't be an output. So if I put in an x, I'm not going to get out a result. Now, what would be the same thing for a square root of a number? Well, we know square root of 1, square root of 2, square root of 4, square root of 16, so on and so forth. We put in those numbers, we'll get a result. You could even put in a square root of 3 and get some sort of decimal answer. I don't know, 1 point something. I don't even know if it's 1.25. But we would get a result. You could do square root of 0 and get a result. The one part you wouldn't get a result is if we put in a negative number. That's where we run into limitations with radicals. There isn't any number or negative number times itself that will ever equal a negative number, because a negative and negative equals a positive. So when we're looking at a radical such as square root of x and we're coming up with a domain for f, the idea is what can I list as a limitation for x? So I know that x could be 0, 1, 2, 3, so on and so forth. So one thing I could say is I could say x is greater than or equal to 0. That's my domain. Or one could say x cannot equal anything less than or equal to 0. I prefer this. It's a way where we're saying what x can be instead of what x can't be. You know, when we worked with this x cannot equal 3, it's easier to list one number than for us to say x equals all these numbers except for 3. So here this is more like an inclusion, where when we're doing rational functions, it was an exclusion. So how do we approach this when we see a question like x minus 3? Or the radical of x minus 3. Well, we know we don't want a negative value inside that radical. So if I put 3 minus 3, that'd be square root of 0. If I put 4 minus 3, if I put, let's say, 2 minus 3, that would give me a negative 1. And this is kind of where my exclusion starts. This is why I run into a negative radical. So I have an issue there. So one thing you could do, and what we're doing with the other class, is take what's inside the radical and set it greater than or equal to 0. So, and then solve for x as an inequality, and then you have x is greater than or equal to 3. And this becomes your domain for a radical function. Just taking a quick look at 2x plus 3, this is a linear equation here. There aren't any limitations with this. If you were to put this into a graph, and you went to 3 and you went up 2 over 1, then we could plot this. This would go on positive infinity, negative infinity. So there is all values of x that are included here. If I were to graph square root of x, it would look something similar to this. It kind of looks like this here. And the shape, and if you look at the shape of that, just a little side note here, I mean, think about it. Square root of 4 is 2. Even if you go all the way up to square root of 81 is 9. Look at the change from here to here, from 4 to 81, it's about 77, but the change in the square is only 7. So if you see, that's why this graph kind of tapers off. But you see that the limitation starts at 0 here. Same thing if I were to graph x minus 3. Well, it's all values greater than or equal to 3. So if I were to graph that, just using my parent function, I would shift right 3 and then start my radical function here, and that's what x minus 3 would look like. So just kind of a little crash course on domains of radical functions. And basically, if you're ever given, it could be anything. Could be anything like a 2x plus 3. You're just going to take that, set it greater than or equal to 0. Because again, you want all your values inside the radical to be greater than 0. You don't want a negative. Divide by negative 3. 2x is greater than negative 3. Divide by 2. X is greater than or equal to negative 3 over 2. And also kind of like a little standardized testing side note, if I had negative 2x minus 3, and I'm looking for a domain, plus 3, plus 3, anytime you divide by a negative with inequalities, it is crucial to change your sign from greater than to less than equal to. So actually this would be negative 3 over 2. So a couple little fundamentals thrown in there. Now we're going to take a look at just your composition as far as f of g goes, right? So we have f of g, f composed of g, and what I like to do is take whatever function I'm using, so in this case, square root of x, and wherever the x was, I put a parentheses. This way I could simply substitute in my g of x, and then this would be kind of my final answer. Call this the composition. But I also have to list a domain here. Now, we just went over that. I just showed you that on the previous page. What's your domain? Well, take what's inside, set it equal to 0. Great. Oh, good catch. Greater than or equal to negative 3 divided by 2. We just did that. So I just actually showed you that. And that's and when I give you guys a free response, you'll see a box to list the composition and the box to list the domain. And that's your 1 point there and your 1 point here. And then we want to continue to look. There's a really good one in here. G of f we'll take a look at. Again, I take my g of f, which was 2x plus 3, and wherever the x was, I kind of just list. I write parentheses. This way I could just simply put in that square root of x. And again, this is just 2 square root of x plus 3. This is your composition. And then to find your domain, take what's inside of the radical, set it greater than or equal to 0. Here my work is done, and I've gotten a domain. This is probably looked at the domain for this. Yeah, one of my little favorite parts of this lesson here, because it discusses f composed of f. I really like this as a fundamental review for exponents. So what are we writing here? We're writing square root and whatever's in the parentheses, but we're putting f right back into f. So you have this kind of square root of the square root of x. And this can be simplified. Now, if x squared is the opposite of square root of x, and if I know the opposite or inverse of 2, we'll do a little inverse symbol there, is 1/2, then I can write square root of x as x to the 1/2. That's like a fundamental exponential rule, which is shown on a test like the SAT or on a college entrance exam. And the idea is here, like square root of 3 would actually be x to the 1/3. So I could rewrite this as, this is why I like this. It's kind of funky. X to the 1/2. Ooh, I messed that up. X to the 1/2 raised to the, that's x to the 1/2. I'm just going to rewrite that. That was not, I want to look good there. X to the 1/2 raised to 1/2. Okay, so here comes into play another exponential review. If I have x squared to the 3rd power, The answer to this would be x 2 times 3, x to the 6th. So basically the idea is any exponent raised to another power, yeah, this is called the power rule. You could actually write this as x to the nm. Now watch this. I have x to the 1/2 times 1/2, which is really x to the 1/4. I just multiply the top and bottoms. Now I could go even one step further and say x to the 1/4 can be written as the 4th root of x. A lot of exponential rules here. We looked at doing like an x plus 2, and this got pretty advanced. So I'm going to keep it just as a square root of x. But I do want you guys to understand this. This is key going into college, going into calculus, going into an SAT. And then the back one, the domain for this question here, again, what's in the radical? It's just simply x. So x, the domain here would be x is greater than or equal to 0. And I think it should be good. The piece is just our g of g, which is an easy one. 2, put the parentheses. Put g inside of it. 4x plus 6 plus 3. And I end up with 4x plus 9. And this would be domain all real numbers here, because anything could go into that. So again, you're looking at, first getting, I'll just put this as a domain of functions f of x and g of x. And then second, you want to come up with your compositions, f of g, so on and so forth. And third, you want to make sure you evaluate your domain by setting x, whatever it is, greater than or equal to 0 when you're finding a domain of a radical, because you cannot have a negative inside a radical there. And that should be it.